The slides I'm going to talk through today are just to give an overview of our Floating Wind Joint Industry Project, which is a programme we've run for the last sort of 5 or 6 years within the Carbon Trust. But before that, I'll give you a kind of brief overview of some of our offshore wind activities. And then as part of the overview of the Floating Wind Programme, I'll talk a little bit about our most recent projects that we've published a summary report on, which is called our Phase 3 summary report. There is quite a lot of detail in the slides, so I'm not proposing to go through all of it, but I'm happy to answer questions at the end, and we will see how we do for time. So just to give an introduction to the Carbon Trust as a whole, for those who haven't come across this before, we are a mission-driven organisation, so not-for-profit organisation, whose mission is to accelerate the move to a sustainable low-carbon economy. We're headquartered in London, and we have offices in Edinburgh and Cardiff within the UK, and most recently an office in Amsterdam as well. But we're also based in the Americas, in South Africa, and in Asia. With over 20 years of consultancy, sustainability consultancy. Within the offshore wind team, so we have an offshore wind team of around 20 people, largely based in London and Edinburgh, but we are looking to kind of get some offshore wind expertise into our Amsterdam office soon. We do a number of different activities, looking initially at programme management. So we deliver a number of offshore wind R&D programmes, which I'll touch on in the next slide, and we collaborate a lot with developers and others in the industry to deliver those large scale either R&D programmes or actual demonstration activities. We also deliver technology and policy advice to different market players, both public and private sector, to kind of help understand market gaps and evaluate solutions. And then we also deliver market insights to international companies, particularly trying to understand kind of what has the UK and the rest of Europe sort of got right in terms of its deployment with of floating wind, and how can other markets learn from that and deliver their own offshore wind objectives. So looking now at our offshore wind programmes, we have 4 programmes that we run as part of our offshore wind team, and you can see the partners that we work with on the right hand side, with a number of them working in one or more of the programmes. Our oldest one is the Offshore Wind Accelerator, which focuses on fixed bottom offshore wind and looking at delivering cost reduction of that technology, looking at a number of different components of that technology to deliver those cost reductions. We deliver a similar sort of R&D programme for floating wind called FLOJIP, or Floating Wind JIP, and that looks at the challenges and opportunities of developing commercial scale floating wind farms, and I'll touch more on that in the next slide. There was a mention in the previous presentation around kind of the need for research on the environmental impacts of offshore wind, and so our ORJIP programme, or Offshore Renewables JIP, aims to look at understanding those environmental risks, particularly as they relate to consenting, to understand what are the kind of appropriate mitigation measures that need to be put in place to minimise those risks, but also kind of streamline the consenting process where we have data that can be applied to upcoming projects. And then our most recent programme, which I'm also involved with, is called the Integrator, and this sits across our offshore wind teams and our energy systems team, who are also based in Edinburgh and London. And this is designed to look at kind of what are the challenges that are coming up in the next few years regarding the actual connection of offshore wind to the onshore network, and what technologies or what techniques can we use in order to minimise the impact to offshore wind developers of potential constraints from a network perspective when it comes to connecting offshore wind. So we're looking at things like the ability for offshore wind to provide ancillary services, the value of having co-located storage with offshore wind, but also more broadly looking at the role for hydrogen and offshore wind, and what's the interplay between producing hydrogen from offshore wind, and where should that hydrogen production be located to maximise the gain for the offshore wind developer and minimise risks to them that they have stranded assets or power that they can't export. So that's a brief overview of I suppose our programmes across the offshore wind team, and now focusing in a little bit more detail on the floating wind JIP. So the floating wind JIP, as I said, its objective is to overcome challenges and identify opportunities for large-scale floating wind farms. It's been running since 2016 and has invested over £5 million in more than 30 R&D projects, and we now have 17 industry partners who've provided over 70% of that funding over the last 5 or 6 years. The projects that we commission are all agreed with the developers, so we go through a kind of scoring process each year to understand what projects are the priority for those developers in the coming phase, and they tend to focus around 5 main areas. So first being electrical systems, which is in particularly at the development of dynamic export cables. Turbine platform optimization is the second. Mooring systems, and particularly understanding requirements for different site conditions and different water depths. And then fourth is understanding the monitoring and inspection requirements, and identifying technologies or methods which would minimise the need for physical inspection. So kind of thinking about the safety considerations as well as trying to deliver cost reductions. And finally, logistics, including both heavy lift maintenance and tow to port maintenance. And that's been quite a focus for the phase three projects. So we'll talk a little bit more about that in the coming slides. This slide you'll be pleased to hear, I'm not going to go through every single square, but it just gives you an overview of the projects that we've delivered over the last 5 years. And going from 2016 to 2019, so our stage 1 and then the first 3 stages of phase 2, there are now summary reports for each of those phases available on the Carbon Trust website for those who are interested in learning more about those particular projects. And I'll focus the next few slides on the phase 3 projects. We also have a summary of the floating wind technology acceleration competition, which you can see on the right hand side, sitting between phases 3 and phase 4. That was a Scottish government funded competition to accelerate technologies across a range of different areas relevant to floating wind. So there is also a summary of that competition and individual reports written by the technologies that were supported through that competition, again available on our website. And the final slide has got some links to those as well. In terms of what we're focusing on at the moment, we're currently delivering the phase 4 projects. So you can see the ones at access and availability, looking at floating wind yield, and then looking at kind of numerical modelling guidelines and standards for developing floating wind designs. And we're currently going through the tendering and contracting phase for the phase 5 projects. So they will probably kick off early next year and run through throughout 2022 and potentially into 2023. The intention is that for each of those phases, once they conclude, we'll write a summary report similar to the phase 3 report and make that available to the public on our website. Sorry, just looking at time. So now looking at the phase 3 project. So this is where the slides get a bit wordy, but I'm very happy for them to be shared after the call and to pick up any questions or to pass them on to colleagues who are expert in these areas. I should say, if you spot me kind of looking down, it's because I wasn't heavily involved in each of these projects, so I'm kind of relying on my notes and reading of the projects for the next few slides. So first, starting off looking at the heavy lift maintenance project. So the issue that we kind of started the project with was that we've got increasing sizes of floating turbines. There's mentioned in the previous presentation of a kind of 10 megawatt plus demonstration project next year, and that is creating demand for larger turbine installation vessels. But we wanted to understand what's the kind of alternative solutions that might be able to kind of make use of smaller vessels and reduce maintenance costs overall. So this project was delivered by ABL Group, working with Waybeck, and the scope of the project was to kind of review state-of-the-art methods for heavy lift operations across all markets, defining then a base case definition of a wind farm and its maintenance requirements, including blade and gearbox exchange for both a 10 and a 15 megawatt turbine. So kind of quite forward-looking in terms of the scales that we're considering, and then doing a some logistics modelling to understand what are the kind of cost and time implications of using each of the different technologies that they had assessed to carry out various operations on both the 10 and the 15 megawatt turbine. So that was looking at assessing kind of both the technical feasibility of the shortlisted technologies, but also the kind of logistics and costs associated with that. And in terms of the key findings, I won't go through all of these, but just to kind of highlight a couple. The first one I think is I suppose the overarching finding is that a lot of the existing fleet of heavy lift vessels would be unable to lift at the hub height required of a 10 megawatt offshore wind turbine. So we can see the technology developing from the turbine side, but there is definitely a challenge there in terms of making sure that there's operation and maintenance equipment available to actually deliver and service those turbines. The one I thought was quite interesting was point 4 as well. So the speed of crane deployment is key to reducing costs associated with component exchange campaigns. So I mentioned that they did some O&M modelling to look at the duration of different operations, and some of those operations included turbine-mounted cranes, and some used vessel-mounted cranes. And what they found was that if you had temporary turbine-mounted cranes, and the duration of the kind of setup and dismantling of that turbine crane could add significant time to the overall duration of that O&M campaign, and often made it then less economically viable than having a vessel-mounted crane. But having said that, there is still a lot of scope for development within the area, and so one of the recommendations that came out of the project was a need to focus on developing turbo-mounted cranes that have a kind of a smoother and a shorter setup and dismantling phase in order to make that type of technology potentially more viable for heavy lift maintenance in the future. So just perhaps to focus on one more. I don't think I'll be able to get through all three, but now looking at the kind of sister projects to the heavy lift maintenance project, the total port maintenance project, again delivered by ABL and WAVEC. Again, kind of looking at a similar issue, kind of a lot of uncertainty around kind of what a total port maintenance strategy might look like, and how do you balance kind of cost and revenue impacts. So things like you perhaps not being able to produce power at a particular chain of turbines for a period of time, with delivering that maintenance safely. So again, quite a similar scope to the HLM scope. So looking at kind of doing a literature review and technology landscaping piece to identify state-of-the-art technologies under development in the total port sector. And then again, undertaking some modelling to understand kind of what would be the process of that, how would that technology fit into a total port maintenance campaign, and what impact would it have on cost and timings of that. And then from that, understanding kind of what are the ongoing kind of technology and development needs for total port maintenance operations, and what innovations are still required within the sector. So again, a lot of key findings, and again, you'll be pleased to hear I'm not going to talk to all of them, but sorry, just skipping through my notes. I think some of the key points are that, and again was mentioned by Daniel earlier, actually, was the need for kind of port infrastructure and current kind of onshore crane lifting heights to ensure that we've got sufficient capacity within different markets to allow for total port maintenance to happen, and for port capacity not to be a bottleneck in that total port maintenance strategy. So I think kind of assessing kind of what capacities we have in what locations, I think will be really key to understanding the extent to which we can rely on total port maintenance in the future, and the extent to which that becomes a limiting factor as opposed to the characteristics of the wind farm itself. Another point I wanted to just highlight was the time that it takes to do a joint of the electrical cables that are left in situ during the total port maintenance strategy is actually quite a time-consuming part of the overall operations and maintenance procedure. And there was some modelling that suggested that actually, depending on the distance to shore and the time that the turbine would be out of action being maintained, that actually there may be a tipping point below which it's preferable to actually not do a full kind of jointing exercise during that operation, but have a chain of turbines out of operation for the duration of that single turbine being maintained. But again, that is just based on the available information we have at the time, and so I think the innovation need for the sector is to develop technologies that allow for a smoother and a quicker ability to reconnect those electrical cables and store them in a way that is safe and easy to do so whilst the turbine is out of action. I think just looking at time, I think I'm going to skip over the mooring systems in challenging environments, but that there is detail in the phase 3 summary reports, which covers all of the detail in the slides. So what I'll just finish with is just coming back to the technology acceleration competition, which is a competition that was funded by Scottish Government over the last sort of 12 to 18 months. And it was tackling 4 challenges related to the development of offshore wind. 2 of them are very you'll recognise from the slides I just presented, focusing on kind of challenges around heavy lift maintenance and tow to port, and then challenges 3 and 4 looking at kind of monitoring and inspection requirements, and the 4th was looking at manufacturer installation and maintenance of mooring lines or technologies that could help reduce the load on mooring lines. So this is now concluded, and there's a summary report available on our website. We supported 8 technologies throughout the duration of the competition, and really pleased to say that some have gone on to commercially deploy their solutions, whilst others have secured funding for larger scale testing. I think it's great that we're kind of the next presentation I think is coming from OREC, because one of the technologies that was supported through this competition is now working with OREC to deliver larger scale demonstration project at their Nice site down in the southwest. So I will conclude there just with a few links to our reports and my contact details if you have any further questions. But very happy to take any questions now, and we'll hand back to Paul and those in Amsterdam.
Thank you, Hannah.
Yep, thanks, Hannah. Thank you.
So, thank you for a very interesting and good presentation, and also for keeping time. I notice we are lagging a little bit behind, so maybe I have to limit it to 1 question if there is any for your presentation. So we're also open for questions online, or if there is anyone online, you can also, if you don't want to type it, you can just tell, I think. No, doesn't work. You have to type it.
So Hannah, I actually had a quick question. So maybe I could ask. In terms of all the projects and programs you've done, are you seeing generally the challenges, the barriers are either technology, economic, or regulatory? Are you seeing a trend in any one of those areas as being more difficult, or is it sort of a balance?
It's interesting. I think our offshore wind accelerator and our FlowJIT programs have deliberately taken quite a global focus. So we've tended to focus on the technical challenges as opposed to specific country regulatory challenges. So I suppose we're then seeing kind of the technical challenges more than we're seeing the economic and the regulatory. But with the latest program, the integrator, which is looking at the integration of offshore wind into a specific country or into a specific network, that is by its nature having to take account of the specific kind of regulatory and market environment in those countries. And we're seeing some really interesting differences. We focused in this first phase on the UK versus Germany, or not versus, or UK and Germany. And it's really interesting to see the differences in terms of the expected need for things like for different flexibility technologies and different ancillary services based on the differences in geography and market structure. So I think we are now seeing a lot more the sort of the regulatory and market challenges associated with sort of the next acceleration of offshore wind deployment.
Yeah, I think the fun's about to start, I think.
Yes, yeah.
All right, thank you.
Yeah, thanks, Paul.